Hi, my name is Katie, and today I'll be going over tutorial 4, which is the Docker Compose Spring Boot and Postgres examples. So this is just backend work working with APIs. So I'll start explaining now. So here we have a tutorial controller. Here we have the cross origin. So this just allows requests from the front end running on port 8081. And then here we have the REST controller. This just marks the class as a REST controller to handle the HTTP request. Next, we have the request mapping. This is the base URL for all the endpoints in the controller. Now moving into the code. So here we have the annotation auto-wired. This is just the inject the repository to interact with the database. Next, we have the annotation post construct and the public void init and the system output print tutorial controller loaded and ready. So this is just cool after the controller is initialized. Next, we have the get mapping. So the get API tutorials title optional. This is just going to fetch all the tutorials all search by title. Um, so you have a try if else and another if and as well as our catch. So this if is going to fetch all the tutorials. So as you can see, tutorials find all for each tutorial's end. Next, the else tutorial repository find by title containing the title for each tutorials. And then edit. So this is just going to search a type for the titles. Then we have our if statement over here. So return new so this is so tutorials is empty. Return new entity HTTP no content. So it will display a 204 if no tutorials are found. Next we have the return again. So return new repository entity. Tutorials HTTP status okay with a 200 list of tutorials and then our catch. Our exception over here. So return new repository entity now. HTTP status. This will return a 500 error. Now we are going into our get. So this is where we will make our get request. So here we have the public repository entity tutorial. This is just going to get the tutorial with the IDs as well as the data. So it's just going to search for the get the tutorials by the ID. Next, it will return a 200 tutorial if it's found and a 404 if it's not. So we can test it out. I am using Insomnia. This is the get. It came back with a 200 OK, and where is it? It will return a 200, and I did not receive a 404, but let us look at it. So I look for ID4 and it gave me ID4, but it does give me all the additional APIs as I just used all the tutorials. But that's fine. Moving on, we have our post request. So here we have the annotation post mapping for the tutorials. Here we have our try now catch. So here the try it's going to save a new tutorial with the publish faults by default. And then it's also going to save the new tutorial with the title and the description, and obviously the publish is false, and then it will return the new tutorial HTTP status created with the 201 is I'll show you now. And then we have our catch block, which is our exception. It will return null and the HTTP status 500 if an error occurs. So now I'm going to just send a post request. Send. So we send a post request. As you can see, we have a 201 status created. Here is our final output for our post request. I did not receive a 500. Next, we have output. So the annotation put mapping is just going to update the existing tutorial. I will demonstrate it now. So here we have our if and our else. It's just so over here we have the tutorial is present, so it's going to give the date, it's going to give the title, it's going to give the description, as well as when it was published, and then it will return a HTTP status OK with a 200 updated, and it's also going to save the tutorial. And if it does go wrong, it will show a HTTP not found for error. So let us try that out. A push request. I'm going to update it and say a movie. I'll change the publish date. I'll leave it as 2000. Why? Let's try. That's why. Why is it not allowed? Okay, I have no idea how to debug that. So it says here the request method is known by the server, but it has been disabled and cannot be used. Why? So we can try. So I want to change this. Um, also just the URL that I have to change, but as you can see, we got a status 200. Okay. Moving on. We have our delete mapping. So the annotation delete tutorials by the ID. So it's going to delete the tutorial via the ID, and then we have our try. So when it deletes by ID, a response will come as an HTTP status 204 deleted, and then we have our catch error, which will leave a HTTP status 500, which is an error. So we can try it. So we must delete by an ID. So I'll use the same one and I'll say delete as we have a 204 deleted. We can delete all the tutorials, but I'm not going to do that. We can. Let me try. Another 204. Now we have get API tutorial. Sorry, I didn't go over the code, but the same as the delete. This is just deleting all the tutorials. So if it's successful, it will leave a 204 status, and if it's unsuccessful, we will get a 500 error. But we did get a 204 status. And then lastly, we have the get API. So this is just going to be all the published tutorial. So Public response entity tutorials find by publish. So it's going to find by publish, which will be true. And if the tutorials is empty, return a 204 if none is published. And then return HTTP status okay 200 whatever else, and then we have an exception which will throw a 500 error if we do get an exception by any of them. So we can try it. What am I doing? Get mapping for all the tutorials. Really, we don't have anything. Let me post this one. See if it will work. Okay, we published one, and now I'm going to send the get method. So you can see earlier I deleted it, nothing displayed. So now I sent the get method, and now we can see it as well over there. Now I am done with the tutorial controller. Moving on, we have the model. So here we have the entity annotation. This is just going to mark this class as a JPA entity, which means it will be mapped to the database table. The annotation table specifies what the table name in the database. If not provided, the table would default to the class name tutorial. Here we have the annotation ID. So it's going to mark the field as the primary key of the table. And then it's also going to specify that the ID will be automatically generated by the database, and the generation type auto lets the JPA provide the appropriate strategy like the sequence identity, etc. Next, we have the annotation column, name title, private string title. So it's going to map this field to a column name title in the table, and also specify the constraints like the nullable, the false, the length equal to 100, etc. And the private just means other classes cannot access this file. That is for everything where you see private. Next we have the name column, name equal to description. This is just going to map the field to the column name description in the table. And then we have the published. So the map, it's just going to map the field to a column named published in the table, and this will store the boolean values true or false, indicating the if the tutorial is published. Next, we have the public tutorial. So by default, no ARCS constructor is required by the JPA. The JPA also uses the reflection to create the instances of the entity when fetching those from the database. Next, here we have the public tutorial string title, string description, boolean publish, so the title, description, and publish. This is a constructor to create a tutorial object with title, description, and publish status, useful when creating new tutorials programmatically. Here we have the get ID, and it must also return the ID. So here is a getter for the ID and no setters for the ID provided. It is auto-generated by the database, so it's just going to get the ID. Next, we have the getter for the title. So this is just going to get the title. Here we have the setter. So this is going to set the title. We have a getter for description. This is just going to get a description and it will return the description. Here we have the setter for the description, so it's going to set a description. Next we have the getter for the boolean. So it's going to get a boolean for the published status. Next we have the setter, so this is just going to set the published status. And then lastly we have our override method. So to override a string, it's just going to provide a readable string representation of the object, useful for logging and debugging purposes. Now we have the tutorial repository. So this is just going to mark the interface as a Spring repository, which makes it a candidate for Spring's component scanning, and it also enables exception translation from the JPA exceptions to the Spring data access exception. Here we have the list tutorial find by publish boolean publish. So it's going to find all the tutorials with the given publish status. Spring Data JPI automatically implements this method based on its name. Find by is the keyword recognized by the Spring Data JPI, as well as publish matches the publish fields for the tutorial entity. The parent publish true or false to filter tutorials by the publish status, and it will also return a list of tutorials matching the given publish status. So here we have list all tutorials find by title containing string title. So it's going to find all the tutorials where the title contains specified keywords, which is also case sensitive by default in some DBS. Spring Data JPA passes the method name and generates the query automatically. It's also going to find by sorry, it's also going to find by and it's also going to find the entries, the title containing where title white as well as the keyword. So the parent title, the keyword, to search in the title is going to return a list of tutorials whose titles contain the keywords. So also we do have our Docker Compose via AML, which we were recently introduced to. So I'll just explain what it is. Let me see where I will start. I think I'll start with a just give me a second. Okay, so we are starting with the Docker Compose via AML. Um, so a Docker Compose YAML file is like a recipe card that tells Docker how to run multiple containers together with what they need and how they must connect. So to break it down so it makes sense, so Docker, think of it as a box that holds your app in everything it needs to run. The container, these are the boxes. Each container might run one part of your app, like the database, the backend, or the front end. In this case, it is the backend. Now, Docker Compose. It's a helper tool that lets us run many containers at once instead of starting each one manually. And the YAML file is a simple text file, usually called like this, the Docker Compose YAML. So this is where you describe the containers, their settings and how they talk to each other. I so also just to explain what goes in here before I actually explain what is going on here. So as we can see, we have services. This is each service is one container. So I'm going to explain it. We have the services, which is the PostgreSQL database. So here we have the image 15. We use the official PostgreSQL image, which is the version 15, the container name, which is the Postgres database name of the container for easier reference, and as well as the restart. Um, always. So this always restarts the container if it stops or if Docker restarts. And then we have the environment. We have the environment, that is the environment variables to configure the database. And then we also have Postgres DB, which is the name like the base code base coder DB. This is just the name of the database to create. We have the Postgres user, which is Postgres. So this is the username Postgres SQL. And then we have the Postgres password, uh, which is Postgres. This is the password for Postgres SQL. Now we have the ports 5432, 5032. This is just to expose the port 5432 on host to connect to Postgres SQL. And then we do have the volume. So Postgres data, var Postgres SQL data. This is a named volume for the persistent data storage, and the data will survive containers to restart the recreation. Next, we do have what we call let me just see. The Spring Boot application service. So here we build the Docker image from the local Docker file. So what is an image? This is where the software used, like MySQL latest, Engine, INX. So the context is the current directory where the Docker file is located, and the Docker file is the name of the Docker file to use. Container name is the Spring app. So the name of the app container, and then the depends on is the Postgres. So this just ensures the Postgres SQL starts before the app. And then we have port 8080 to expose the Spring Boot app on port 8080. The environment is the environment variables for Spring Boot configuration. And then we have the Spring data source URL. So this is the JDBC Postgres SQL. This is to get into our SQL database. And then we also have the JDBC URL to connect to the Postgres SQL container. And the Postgres here is the service name which Docker Compose resolves automatically. So here we have the Spring data source username, which is Postgres. This is the database username. The Spring data source password, Postgres, which is the database password. Spring GPA Hibernate DDL auto is the update, and then also we have the Hibernate setting automatically update the DB schema based on entities. So here we have the Spring GPA properties Hibernate dialect or Hibernate dialect PostgreSQL dialect. This is where we hibernate all the dialect and tells the Hibernate how to generate SQL for the Postgres SQL. Lastly, we do have the volume. So we have the Postgres data and name volumes to persist Postgres SQL outside of the container. Um, Now we are going to the Docker file. So the Docker file is a simple text file that just acts like a recipe for building a Docker image, and it tells Docker step by step how to set the environment for the app to run. So yeah, it also contains the Docker image, which is the blueprint that the app needs for dependencies and settings. The Docker file is that recipe card that explains how to build that image, and the Docker container is just going to run the instance of the image. So here we have stage 1. To build the Marvin project. So from Marvin 3.8.5, open the JDK 17 as build. Use an official Marvin image with OpenJDK 17 for building the project. Its build names the stage build so we can reference it later. Next, we have the work directory, which is the app. This is just going to set the working directory inside the container, which is the app, and all the following commands will be executed in this directory. So here we have the copy from XML. This is just going to copy only the form XML first, and then it's going to allow Docker to catch dependencies if form XML doesn't change. Next, we have copy source. So the main logic of the app, where we have our controller and our repository and our model. So this is just going to copy the source code into the container in the app source directory. And then we have the run Marvin clean package skip this. So this is just going to run Marvin to power the project. It's going to clean and remove previous builds. The package compiles and packages the app into a jar. And then it also skips the test and skips running tests for our build for Docker image. And then we have stage 2 from Eclipse, run from 17 JDK. So it's also going to use a smaller runtime image with the JDK 17 to run the app. And it's also going to separate the build tools, which is Marvin, from runtime in a smaller final image. And then the working directory, which is the app, it's going to set the working directory for the runtime image. Then we have the copy from bulk, which is the app target jar app.jar. So it's going to copy the jar bulk in the previous stage to the runtime image, and it's also going to use the wildcard to ensure that it works even if the version or artifact name changes, and then the jar will be named app jar in the container. And then lastly, we do have our entry point, the java jar app.jar. This is just going to specify the command to run the Spring Boot app when the container starts, and then the entry point just ensures that the container always runs the app.